power, represented by the variable P with units of watts, is the time rate of expending or absorbing energy. That is, power is the time rate of change of work. Now, we could apply the chain rule. If we have dW dQ times dQ dt, we see dW dQ is simply our voltage, and dQ dt is simply our current. So power is our current times our voltage. To determine the work of an element, either the quantity dissipated or supplied, we just have to integrate power between their bounds of interest. That is, our work would be the integral of T1 to T2 of power d tau. Now, let's look at the mathematical formulation of power in an example. Assume the current into the terminal of an element is 20 e to minus 5000 t amps, and our voltage potential across the element is 10 e to minus 5000 t kilovolts. For all time t is greater than or equal to 0. We want to determine the power supplied to the element at 1 millisecond, and the energy delivered to the element. To do such, we recognize that our power is simply our voltage times our current. Our voltage is 10,000 e to minus 5,000 t volts, and our current is 20 e to minus 5,000 t amps. Or we'd have 200,000 e to minus 10,000 t watts. Now our power evaluated at 1 millisecond would be 200,000 e to minus 10,000 times 0.001, which is equal to 200,000 e to minus 10, or 9.08 watts. Our energy delivered to the element is found by integrating our power between our bounds of integration, from 0 to infinity. That is, our energy is equal to the integral from 0 to infinity of 200,000 e to minus 10,000 t dt, which is equal to 200,000 e to minus 10,000 t per minus 10,000 evaluated between the bounds of 0 and infinity. This is equal to minus 20 e to minus infinity minus the quantity minus 20 e to the 0, which is equal to 20 joules. Now, let's consider quantifying power dissipated and supplied by an element. Consider the following element, where we have 2 amps entering terminal A, and we have a voltage potential VAB of minus 4 volts. We want to determine our power dissipated. Currently, the element is represented in a passive sign convention. That is, our current is entering our high potential terminal and exiting our low potential terminal. That is, our power dissipated is going to be 2 amps times the quantity minus 4 volts, which is equal to minus 8 watts. Now you may be wondering, how do we have minus 8 watts dissipated? Now let's consider power supplied, and this will answer that question. If we look at our power supplied, our current would enter our negative terminal and exit our positive terminal. The minus 4 leading our voltage potential, describing VAB, allows us to flip the terminals. That is, A becomes our negative terminal, B becomes our positive terminal, and we increase our potential by a quantity of 4 volts. Thus, our power supplied, when our circuit element obeys an active sign convention, is 2 amps times 4 volts, which is equal to 8 watts. We are supplying 8 watts, or we are dissipating negative 8 watts. Thus, since we are supplying 8 watts into our system, this element is a source.